Here for example 3, we're going to look at finding out different properties like quality and specific volume at different parts of the phase diagram and at different parts of the steam tables. So for part A, we're asked for, at a pressure of 300 kilopascals and 0.5 meters cubed per kilogram specific volume, what is the temperature at that point? So if we look at table B6 on page 646 in appendix B of Felder, we find that we have a pressure table there. So it goes down in the left-hand column from 1.1 bar down to 7 bar, and there it gives you the corresponding saturation temperature. So if we look at, for 300 kilopascals, 300 kPa and 0.5 meters cubed per kilogram, this is just equal to 3 bar. So we need to convert that into because our table gives it in bar as well. So we need to know how many bar it is. So for 3 bar, if we go down the left-hand side, we see that that corresponds to a saturation temperature of 133.5 degrees C. And if we look a couple columns over, we can see that there's specific volume data for water and for steam. And our value of 0.5 falls between the water and the steam values of 0.001074 and 0.606. That means that we have a state fixed within the two-phase region here, and it's at 3 bar, which means that the temperature has to be 133.5. What we've identified is a specific volume in the two-phase region where it's boiling. So if we look at this, and that's as simple as it is for this one, if we want to identify it, we can see, well, this is the saturation or the boiling temperature, and this is for 3 bar. So this is a TV diagram, so you're not going to see pressure on it unless we put an isobar in there, which would be this right here. So that's where our pressure shows up. And it's going to be the same pressure along here of 3 bar. And then this isobar going down here would be 3 bar as well. So that's easy enough. And then we know from the table that it's 0.001074. This is in meters cubed per kilogram units. And this one is 0.606, like we said from before. So this is the saturation liquid and the saturation vapor temperature, or specific volumes here. And we know that 0.5 lies somewhere between those, so we can identify it's maybe up around here. This is 0.5, so that's where it lies on our thermodynamic phase diagram here. 0.5 meters cubed per kilogram. Now that's relatively straightforward, so we've identified it here and we found the temperature of interest. So that's fine. But what if we wanted to determine what the actual quality is here? We're not asked for that in the problem, but if we do want to determine what it is, all we need to do is use our formula that involves quality. So this is our known specific volume. Then we have to incorporate the specific volume for water plus quality times specific volume for steam minus specific volume for water. So we know this is 0.5. That's what we're given in meters cubed per kilogram. And that's equal to our established 0.001074 meters cubed per kilogram of water plus our unknown quality. We don't know what percent is vapor and what percent is liquid within this two-phase region. And then our specific volume for steam minus our specific volume for water again. And this is essentially a little interpolation between those 2 points. And so if we solve for x equals 0.825 or 82.5% quality. And we can further use this to, if we were asked, we could determine what our specific internal energy and our specific enthalpy are at this point. Because now we've fixed our state, we've got our temperature and our pressure and our quality, or in this case, our specific volume was another way to say that. That and quality determine how to fix a state in our two-phase region. So now if we wanted to find what is the specific enthalpy, what is the specific internal energy, we can do the same thing for internal energy. Now we know what our quality is. And so we just have to put in these values, which are also found in the table, along with specific volume. So if we do that, this is 561.1 kilojoules per kilogram. And this is 2543. And again, 561.1 kilojoules per kilogram. So this ends up being 2196.2. That's 2196.2. And here we've got the H, the specific enthalpy of water, plus again our quality of 0.825. This is what tells us how much percentage of it is steam. So 82.5% is steam compared to 17.5% that's water. So we know that it's going to be closer to the steam properties than it will be to the water properties, because it's closer to the steam side, the saturated steam side of the envelope. Here we've got 561.4. Remember, enthalpy and internal energy are related by that PV term, or flow work in an open system. So this is 2724.7 kilojoules per kilogram minus 561.4. And so when we evaluate that, we get 2346.1 kilojoules per kilogram. So we weren't asked for any of this in the question. We were only asked for temperature, which was actually quite straightforward because we could just find it. We knew that our specific volume was in between the two specific volumes for the saturated vapor and the saturated liquid at that temperature and pressure, but we can still find a whole lot more. So that's part A for example 3.